So we're talking excluded values. In some situations, it's a little easier to come up with those excluded values than in others. All right. So what value or values for x make the expression, well, the given expression undefined? Now, yesterday we talked about how to test values when you were already given them, right? You put the expression in, and then you go from there. The way to figure it out kind of it involves that process too. So let's start with typing the equation in for y equals. All right, so just like we did yesterday, that shortcut method, hit the y equals key and type in the expression. Alpha y equals n over d. X plus 7, x squared minus 16 in parentheses, open parentheses, x minus 9. All right.
Where are the spare calculators?
Bottom drawer, the big drawer. All right, so now you have that expression in there. So when you start thinking about values that may or may not be excluded, you have a way of testing them, all right? So what I want to do is determine, so I'll rephrase the question, determine any value of x that makes the denominator equal to 0. All right. So when you're dealing with multiplication, that could happen if this factor is equal to 0, and it could happen if this factor is equal to 0. So what I'm going to do is I'm gonna figure out what x value is going to make x squared minus 16 equal 0. So I'll do x squared minus 16 equals 0. And I'm also going to do x minus 9 equals 0. All right, when I'm solving equations, I want to isolate x, right? So in my red equation, what's my first move? Add 16. Now I have a power of 2. I want to undo a power of 2. What do I do? Square root it. This is going to be a recurring theme in the course. What is the square root of 16?
4.
Or negative 4. So we use a plus or minus symbol. So plus on top of a minus means that the number that follows that can be either positive or negative. All right? It's a nice, nifty way of writing it. So we have that. Now I want to solve the other equation, much easier process because it's linear. I want to solve for x, I'm just going to add the 9. So x equals 9. All right? So the values that make the expression undefined. So I'll make a little note here. Undefined if x equals plus or minus 4 or 9. All right. Now, the calculator. This is a way that you can check your work, but it's also a way, depending on the types of numbers, where you could actually get these values without doing the algebra. It doesn't always work, but when it does work, it's a time saver. All right, so you have your expression in, we quit out of there. All right, my little sign there right next to syntax error means you did something wrong. All right, the sign I promised I'd put up says to find y given x, type the equation y1, which we already did. Select alpha trace y1, so alpha trace, select y1. And and then type in the given x value. So we have 3 different values that I could plug in. I could plug in a -4. Make sure it gives me an error. It sure does. If you hit the up arrow twice and then hit enter, you could recall that calculation. And then just scroll back and delete the minus, make it a plus. Another error. All right, so that one's verified. Hit the up arrow twice, hit enter, recall that value so that you're not hitting alpha trace every time. Change the 4 to a 9, error again. So error, error, error. We just verified that these 3 things are our answers. All right. There's another way that we could have gotten error without having to discover these values algebraically first. So one sec. So the way to handle this would be to hit second graph. All right. My settings are off, so let me just fix that. Thank you.
You're welcome.
So I'm just changing my settings back to normal. All right, so hit second graph. A203 is where I'm going next period. All right. All right. So that brings you to a table of values. So if I wanted to graph this equation, like if it were an equation, right now it's an expression, but if I wanted to graph it, then these would be the points that I would plot on XY axis. And so I would plot the clean ones, you know, the ones that are easy to estimate. But really, that's not what I'm here for. I'm here to get a sense of where the errors are. So just by looking at it, I could see I have an error at 4. If I keep scrolling, I have an error at 9. It's still trial and error, but if you scroll around sufficiently in both directions, you could pick up all 3 errors. But you could see the clear and obvious, hopefully the clear and obvious drawback, and that is the X list is only integer values. What if my excluded value is a fraction? It's not going to show up in the list. All right, so you need to know the algebraic approach, but if you're dealing with whole number values, so we learn about number sets. If you know that you're only dealing with a set of integers, then you could go right into the table and get your values without doing any work whatsoever. Right, okay, well maybe you consider putting the equation in work in y equals, but that's only because you don't have a lot of experience with that. Flash forward 2 months, that's not going to be considered work anymore. You'll have so much experience with that it'll be second nature. All right, sorry, you had a question?
Do you have to use the calculator, like the alpha and like y, or can you just do it on paper?
You're welcome to do anything you want on paper, but there will be some tests throughout the course where you just won't be able to finish if you don't use the calculator. All right, so there will be some where it just takes too long to do it algebraically, that you're gonna want to do it on the calculator. All right, and you know it's one of those things where I believe in the calculator, but one of the reasons why I push it so heavily has to do with that, yeah. But the other reason is because state requirements and also the requirements as you go into college is they want you to be proficient with both the hands-on mathematics and also technological applications of mathematics. All right, so like you're not satisfying the requirements for even graduation if you don't have a sense of the technological aspects.
On the test, if we like forgot how to do this, can you help us with that?
Generally, no. It depends on what you're asking, though. Like somebody asked me on the last test where the square root button was. I don't have a problem helping with that.
Okay.
How to plug the expression into Y1 and use alpha trace? Probably not.
Just like how to get to that screen. Like if you ever have to ask that, like just clicks. I know how to do it, but like.
That's borderline because the way I look at it is you're using this approach to not do it algebraically. So then if I show you how to use this approach on a test, then the question becomes, what knowledge are you demonstrating?
Yeah.
You know? So I would say if you're gonna use the graphic calculator approach, that you gotta be ready to rock and roll with it. All right. And in some cases, you're going to say, the calculator approach is too complicated. I don't want to do it that way. But in other cases, you're going to say, whoa, that saved me 15 minutes of work. I'm definitely doing it that way. You know, the one thing I would ask you to do at this point is reserve judgment, because there are plenty of people. I have a lot of experience with this course. There are plenty of people who decide day one, forget this calculator thing, I'm never using it. And then they spend the entire year struggling in the course. Right? And you could have made your life so much easier. Right? So number 5, and that statement is so important that I'm putting it on the video and posting it on YouTube. All right, I'm putting that out there for the world to hear.
Yeah.
All right, so that I promise you can rewind this tape back when we're finishing up the course in May, and know that I was speaking the truth. All right. All right. So number 5, consider the equation x over x minus 4. We want to find the excluded values of x that lead to a denominator of 0. All right. Well, obviously, I think it's fair to say obviously, 2 over 3 is not something I'm worried about. There's no way 3 is going to become a 0. It's the x minus 4 that I care about. So if I'm doing it by hand, I would say x minus 4 equals 0. Solve for x, so add 4 to both sides. And I get x equals 4. All right, so undefined if x equals 4, so we need to exclude, so therefore exclude x equals 4. All right, because x equals 4 is a bad number. All right, that should not have been the hard part. And same idea with number 6. Those pieces should not have been the hard part. When you get to part B, where it says solve the equation for x, that's a little bit of a different story, because we're dealing with a proportion. Fraction equal to a fraction. When you have a proportion, the best technique for solving the proportion is to cross multiply. There's other ways to do it. There's always other ways to do it. But this is the best way to do it. All right. So we're looking at 3 times x equals 2 times x minus 4. Now we're going to solve. All right, 3 times x is just 3x, so we're good there. Now if I distribute the 2, I'm going to get 2x minus 8. What's my next move? Subtract the 2x. So I'm going to get x equals negative 8. Now, here's the big thing. So I have my solution for x. X equals negative 8. This excluded value of 4, it ended up being irrelevant. It ended up not mattering at all. But if I just did all that work and I got x equals 4, x equals 4 is a bad number. If I got x equals 4, I'd have to cross it off and say, well, that can't be the answer. So no solution. All right? So you got to be on the lookout for that sort of thing. Now, in number 6, you could kind of streamline the process a little bit. You don't always have to show the work. Find the excluded values of x. If you see it immediately, you could just make the statement that x cannot be equal to what? 2. That's the same as saying undefined if x equals 2, exclude x equals 2. All right, much more streamlined. All right, so I'm going to cross multiply again. I'm going to rewrite my equation down here so I can mark it up properly. Now there's little shortcuts. There's a different way to tackle this one, but I want to have a consistent approach, so we'll do it the same way. All right, and then I'll show you how you could have streamlined it a little bit. So we're looking at x minus 2 times x plus 3 equals 5 times x minus 2. All right, so this is an important step. We have a common factor on both sides of the equation. What do you think I can do there? I can simplify it, all right? So basically this is equivalent to me saying, all right, I'm gonna divide both sides by x minus 2, the whole factor x minus 2. If I do that, we're looking at boom, 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 boom. So a total of 4 booms. All right, because you could cancel entire factors. All right, instead of distributing it all out, which would be a little bit of a mess, you could do this. So what I was getting at before is if you're looking at a proportion, and so again, proportion is fraction equal to a fraction. If there's a common denominator on either side of the proportion, you can cancel it out immediately. So I could have just canceled the x minus 2's out immediately. All right, if there's a common numerator, I can cancel them out immediately. All right, that's a little bit more advanced. We haven't really done much with fractional equations yet, so we'll do more of that later, but it's a next level algebraic technique. So if you get it, you can use it. If you don't, then you just do it this way. All right, at least for now. So we get x plus 5, geez. X plus 3 equals 5. Subtract the 3. Exactly. You would say x equals 2, which means no solution. So therefore, no solution. Couldn't have said it better myself. All right, so I'll just repeat it. Because x equals 2 is the excluded value, and we just got x equals 2, so it has to be no solution. All right, and so the last problem here on page 29 is just asking you to write an equation that would have the restriction of x cannot be equal to 10, and really you can write anything you want. So let me say 2 over something equals 7. I don't know. Give me the something. Boom. X minus 10. So this is the part that you need to have in there. Everything else you can make any way you want. You can make any equation you want as long as at least one denominator has an x minus 10 in it. Because that would make it so that 10 would cause it to be undefined. All right? So there really is no wrong answer here as long as it's an equation. It's an equation if it's got an equal sign in it. All right? Two sides with an equal sign smack dab in the middle. All right? So anything that's got numbers and letters with an equal sign in it, you're going to call that an equation. And it's got to have an x minus 10 on the bottom of a fraction. Everything else could be whatever you want. You put a smiley face as your numerator if you want. Doesn't make a difference. All right? The bottom just needs to be x minus 10, precisely. So a good example of a smiley face right over there. With weird eyebrows, of course.